Hello, everybody. I'm going to work the two example problems on the assignment number 8 on Charles Law to help you learn how to use the formula. It's not a difficult formula if you remember the cross multiply and divide rule. So let's take a look. First off, this is Charles' law for gases. Remember, the temperature and the volume vary directly. If the volume gets bigger, the temperature gets bigger, so that the ratio stays the same. The volume gets bigger, the temperature, if the volume gets bigger, the temperature gets bigger. The two ratios have to be equal. So we can write the two ratios equal to each other. Now, one thing we do need to remember is the temperature, when you're using Charles' law, must be in Kelvin, not Celsius. How do we do that? Well, if you know the Celsius, you take the Celsius degrees and you add 273, and that will give you Kelvin. Okay? So take the Celsius, add 273, and that will give you Kelvin. All right, so let's take a look at these examples. The first one says a gas is heated so that it expands from a volume of 1 liter, so that's where it was initially, expands from that to something else. So this is the initial, so I'm going to write it down. The initial volume equals 1 liter, okay? And it goes to a volume of 1.5 liters, so that's the second volume, the final. Okay? And it says that the initial, it actually says initial temperature of the gas is 5 degrees Celsius. So the initial temperature equals 5 degrees Celsius. And they want to know what is the final temperature of the gas. So here's our unknown. They want to know, what does TF equal? Okay? So notice 1, 2, 3, 4. 1, 2, 3, 4. All right? Now, before we can actually do anything, we need to convert our temperature. It is in Celsius degrees, so all we have to do is add 273 to the 5, and we get 5 and 3 is 8, 278 Kelvin. So that's what we're going to use. All right? Now, let's look at what we do with the formula if we're looking for TF. All right, since TF is right here in the denominator, we're going to use the trick where we cross multiply and divide. So let's try that, okay? If we cross multiply, we multiply the things that make an X, like this. Okay, so we're going to multiply VI and TF. So I'm going to write that out. VI times TF. And then we take TI and we multiply by VF. TI times VF. Okay, so now we cross multiplied. Now, remember, we're looking for the final temperature. Here it is right here. Okay, so the divide part, remember I said cross multiply and divide. Well, we've done the cross multiply, now we're going to divide. But by what? Well, leave the TF where it is. We've got it where we want it. So let's divide the VI away. So we're going to take it to the other side. We're going to divide it over. All right, so over VI, over VI. And right here, it cancels out. All right, and so that leaves you TI times VF over VI, and that should give you TF. Okay, so now let's plug the data in. So TF equals TI, here it is in Kelvin, 278 Kelvin, times VF, which is 1.5 liters, over VI, which is 1 liter. Okay, so now you see why it's so important to know the difference between which ones are initial and which ones are final. Because when you plug them in, if you don't put them in the right places, you will not get the right answer, okay? So it's very important that you read carefully and determine what the initials are and what the finals are. What was it doing first? Then what did it do later? Okay? Now, we stick that into our calculator. All right. Turn it on so you guys can see that. There you go. That's not too bad. All right, so we say 278 times 1.5, and then we're going to divide by the 1. Well, anything divided by 1 is just itself. So we get 417. But 417 what? Well, let's take a look. All right. We have a liter in the top and a liter in the bottom. They cancel. That leaves Kelvin. And remember, we're looking for the final temperature. So that does make sense, doesn't it? Okay. So we start by identifying our initials and finals, okay, from what's given, and then what are we looking for? Then we take the formula, we cross multiply, we look at what we're trying to find, and we divide the other that we don't want over to the other side, okay? That's how we do it. Then we can correctly plug in and crank out an answer. Let's try the second one. Let's go through this again. Okay? Let's take a look. If a 5-liter balloon at 25 degrees Celsius were gently heated to 30 degrees Celsius, what new volume, hang on, clock again, what new volume would the balloon have? So we want the new volume, the final volume. So I'm just going to go ahead and write that right here. Final volume equals what? That's new, not old, not initial. So let's look back here. The 5 liters, that must be the initial volume. Okay? And it says the 5 liters is at 25 degrees Celsius, so that must be the initial temperature. And it says it's heated to this new temperature, so that must be the final. See, it just takes a little common sense to figure this out, guys. Common sense. It doesn't take rocket science intelligence to do this. Just some common sense. You're going from 5 liters to some new volume because your temperature is increasing from 25 to 30, initial to final, okay? Now, once again, before we can start doing anything with our formula, let's first take care of these. All right, these need to be in Celsius. They are in Celsius. They need to be in Kelvin. So let's add 273 to each one. Okay, so we get 8, 9, and 2 Kelvin. Right here, 273. We get 3, 10, and carry the 1, you get 303 degrees Kelvin. There we go. Now we've got them in Kelvin. So let's take our formula and let's cross multiply and divide. If we cross multiply, again, we're going to get VI times TF, all right? VI times TF. And if we do the other one, we get TI times VF. And actually, I'm going to put that one right here, TI times VF. Now, why did I do that, you ask? Well, because I know we're looking for VF. So I made sure I wrote that product on this side, okay? Now all we have to do that we've cross-multiplied is we get rid of the one we don't want. We want VF right here. So we divide away the one we don't want. So we divide by TI there, and if we did that, we got to do it over here too. Now, the TI cancels and leaves us with this. So let's plug into the formula now. VF equals, VI is 5 liters. TF, remember, we got to use the Kelvin one, 303 Kelvin. All over TI, 298 Kelvin. Okay, now look at the units this time. The Kelvins cancel and leave liters. So now if we chuck it into our calculator, we should get volume in liters. So we're going to say 5 times 303, then divide by 298, and we get, well, it says 5.0838. Let's just say 5.1, okay? 5.1, because if you'll notice, our original volume is only to 1 decimal place. So our answer is going to be VF equals 5.1 liters. Okay? There we go. All right, so remember the rule. You cross multiply and then you divide away the one item in the product that you don't want and keep the one that you do want. Okay? Cross multiply and divide, cross multiply and divide, cross multiply and divide. Remember that trick. Now, also don't forget, in our practice problems, the temperature is given in Celsius because that's what they use in science labs. They use Celsius thermometers. So guys, you've got to add 273 to each temperature first to get Kelvin. Then you can stick it into the formula. Okay? All right, I hope this helps. If you still have questions on the 4 problems, and look here, I put them right here for you with the steps. So you can follow the same steps, okay? And if you still have questions, please message me in Schoology. Okay? Thanks, guys. Bye-bye.